Now you understand the concept of machine learning. Let's look at the artificial neural network, which is necessary to move on to deep learning. Here we have a word neural network, and we have neurons in our brain. Let's briefly talk about the human's neural network. This is what the human's neural network looks like, and this is called a dendrite. Dendrites receive signals from other neurons. The received signals are accumulated in the dendrites, and neurotransmitters are released through axon terminals back here under certain conditions. This goes to the dendrites of the next neurons. A perceptron is modeled after this, and is the most basic unit of the artificial neural network. In fact, they almost look identical. Look at this. This is the dendrite. It receives signals from other perceptrons, and the sigma, it adds up all the signals. After adding them up, it sees what conditions are met. Checking these conditions is called the activation function. It moves on to the next neurons through this. It has the same structure, but there is something more. The weights, the role of which is, even for humans, the strengths of connections among the neurons all vary. Some neurons are strongly connected. It means, with such strong connections, if a neuron in front reacts, a neuron in the back reacts, too. Other neurons have very weak connections. Weights are used to represent this type of relationship among perceptrons. Weights are multiplied when a signal is received from other neurons. Multiply the signal from neuron 1 by 0.9. Multiply the signal from neuron 2 by 0.1. Multiply the signal from neuron 2 by 0.2. Adding them all this way and sending the signals to the next neurons by activation functions is the basic mechanism of the artificial neural network. What we can do with this, there is little we can do with one, though we can do a lot if we build it deep. Deep learning is done through a deep neural network. In a DNN, the yellow one is called a hidden layer. We have all the names up here. The red one is an input layer, the yellow one a hidden layer, and the output layer, the way out. We don't really know what is going to happen in this middle one. As this picture shows, we input an image of a cat, and then, if this task is to distinguish between a cat and a dog, we should make it say it's a cat when an image of a cat is inputted. The task of the neural network is to say it's a cat when a cat image is in, or say it's a dog when a dog image is in. So, if it is able to say it's a cat with a cat image, we don't know and don't need to know what is being computed in this yellow area. This is the hidden layer. A network with more than 2 hidden layers is usually called a DNN, and like I said earlier, it has to be able to say it's a cat if a cat image is inputted. Usually we have probabilities here in this output. We call this image classification. It comes like it's A0.9 probability of being a cat or A0.1 probability of being a dog. The goal is to train it until it reaches the 100% probability of being a cat. Training it by inputting data and giving correct answers is what machine learning does like this. Building a model in neurons with more than 2 hidden layers is called a DNN, and the training process through the DNN is what we call deep learning.